This is Leetcode problem 91. Codeways. A message containing letters from A to Z is encoded to numbers using the following mapping. A maps to 1, B maps to 2, and Z maps to 26. Given a non-empty string containing only digits, determine the total ways to decode it. So essentially, you'll have cases like the number could be 12. That can stand for 1 stands for A and 2 stands for B, or 12 stands for L. So for 12, those are the two combinations. So essentially you have 2 paths to take. When you encounter the number 1, you can convert that to A and then consider the rest of the numbers and decode them. Or number 1, then you see the number after that, which is 2. So now you have 12. Decode that as L, and then see if there are more numbers encoded. So those are 2 paths you can take, and then either path that you've taken, you still have more numbers to decode, and you keep doing this, making a choice of the 2 paths until you have decoded all the numbers. So this sort of looks like an inverted tree structure where you make a decision, you take one of the 2 paths, and each of those 2 paths you can make a decision, go to 2 more paths in there until you have decoded everything. So that maps very well to recursion. So whenever you have this kind of a tree structure, inverted tree structure, recursion tends to do a good job of solving that problem. So that's what we are going to try. So let's create a set that will contain all the decoded strings. Now in recursion, the first thing that we do in recursion is we figure out when the recursion ends. Let's call this inner loop. It will have the current string that has been decoded and what is to be decoded. So the end condition is when the length of to be decoded becomes 0, so nothing's left to be decoded. Let's put this here. So let's add the current decoded, which is the final, to this set. At the end, we'll find out its length and output that. So this is when the loop ends. What do we do otherwise? So otherwise, we have two conditions. Is the current number 1 or 2? Or something else. So let's say it is 1. Now, if there are more numbers after this one, and this is less than, actually no, it doesn't matter. If this is greater than 1, then we have essentially two situations. We take the current encoded and we add the character from 1 plus 64. 64 because that's how it's recorded. So if you do a CHR of 65, you'll get A. So that's why 1 plus 64. So we'll get that. And to be decoded, we'll take everything from 1 onwards. So we want to remove the first string from this to be decoded stuff. And add that here. Okay. The other thing Actually, there's a mistake. If what's next to be decoded starts with 1 and there is something more, then we will take both of those. So essentially take 2 numbers from the string to be decoded. So current decoded will be the previous one plus we will take an integer of and we'll take the first 2 numbers that will be 0 till 2. So that will be 0 and 1. We'll convert that into an integer. We'll add 64 to that. Convert that into a character. Add that to the current decoded new. And the decoded new will have 2 onwards. Okay. And this we send back into the recursion. And if this had only 2 numbers in there, then this will be an empty string and that will end the recursion there. So same story as if we have the next to be decoded starting at 2, the length is greater than 1 and because we have up till 26, so this character we will convert to number should be less than equal to 6 because the characters are from 1 to 26. If that's the case, then this remains the same. This remains the same, this remains the same. Okay. If these conditions are not the case, then we have a standard formula. So only in the above 2 cases there are 2 branches. Otherwise it's pretty standard. You just take the first letter, decode that, add that to the string, and send it to recursion. So the new encoded is just one encoded is reduced by 1, and then we send this into recursion, and the output will be you want to return the length of this set, and let's call this function to begin with. So current encoded in the beginning will be an empty string. To be encoded will be what's given in the function s. So that should be it. Let's run this. Okay, we have a problem. So there were two bugs in there. One was the one should have been in quotes, because I'm looking for a string here, character, and anytime we do recursion we check for the end condition where the recursion stops. I had forgotten to put a return sign there. So once I did that, I ran it and it looked fine. Let's submit it and see if it accepts it. So 163 out of 258 passed, so it's generally fine, but it has some. So essentially the code passed 163 test cases, so it's generally working, but there are some corner cases that we need to figure out. So let's fix this corner case. If the input is 0, well, we have no characters defined for it, so it should return just 0. So if the length of the current encoded is equal to 1, and to be decoded, and the first character is 0, then just return. So that should take care of this one. Yeah, what if there is more than that? So how many have we fixed? 187. Let's remove the length condition. Or rather, let's make it the length is greater than 1. Then we check if this is 0. Now what's the issue? Greater than 0. Okay, this is a time limit issue. So there's probably a more efficient way of doing this, but recursion did solve 221 of the 258. I think that's good enough for now. We'll leave it there.